Hello, Physical Science. This is going to be a tutorial on the homework called Bringing It All Together. So some of the concepts that we are bringing together are things like force diagrams with different types of forces. So here we have the force that is applied, the force of friction that is resisting the applied force, and let's say, just for example, that we have 10 newtons of force applied and we have 5 newtons of friction. We also talked about this concept called the net force. And the net force is kind of like the leftover force. After we have 10 newtons this way, well, 5 of the newtons get canceled out. And so what we're left with is a 5 net force to the right, 5 newtons. Another thing that we talked about is the relationship between force, mass, and acceleration. So we can calculate for a lot of different forces. We can calculate for the force of friction, force of acceleration, force of gravity, a lot of different things. This is always going to be measured in newtons. So, newtons. The mass is always going to be measured in kilograms. And that's going to be how much matter something has, how much of the stuff there is in an object. And then acceleration is how fast an object acceleration is the change in an object's velocity over time, so how quick it's going to speed up or slow down. Last concept that is going to be included in this homework is the relationship between mass and weight. Remember, mass, how much stuff something takes up. Weight is actually a force, so the amount of newtons, or the force in newtons that gravity is pulling. No matter where you go at in the universe, at any moment, you are going to have the same amount of mass because you're made of the same stuff. But if we could snap our fingers and put you on another planet where gravity would be different, your weight would be different. So another way of writing out weight is just calling it the force of gravity. So let's get started with our first problem. All right, first of all, whenever you're looking at one of these problems, obviously read through it, circle all the important information. So for example, we see something about 15 newtons, 3 newtons, 50 kilograms, but make sure you go ahead and read it. But then always know where we want to end. Whenever you're going on a trip, you need to know your destination. And so we're going to be looking at acceleration, okay? So whenever we get down to this, to our triangle, F equals ma, we are going to be solving for acceleration. And before we can solve for acceleration, we need to know the force acting on this object, and we need to know the mass that that object has. So let's see if we can figure that out together. Force applied, we learn it is 15 newtons because the sister pushed her brother with 15 newtons. The force of friction, I circled it right here, is 3 newtons. The mass is 50 kilograms. And our question is solving for acceleration. So to draw that force diagram, here is the brother. We have, 15 newtons of the applied force. Sorry, that got really messy. Opposing it, we got the force of friction, 3 newtons. And this force right here, this force has to be the net force. So once it's all said and done, if we have 15 newtons pushing to the right, 3 newtons pushing to the left, what we have left over is a 12 newton net force. And it's going to the right, okay? So there's your force diagram. A little bit sloppy, but that'll work. Now we actually know what our force is. We already know what our mass is because it was given up above. And we're solving for the acceleration. So I'm going to circle what we know. And then the equation is going to look like this. A equals F, the force, divided by m. The force we learned the net force we calculated up here, and we got that information right here. Force is 12 newtons divided by the mass, which is 50 kilograms. And when we calculate that out, we get a grand total of 0.24 meters per second squared. Now, how did I know to put meters per second squared? Because we're solving for acceleration. I'm going to box my answer in, and there's a full credit problem right there. All right, let's do number 2. Number 2 is a little bit more difficult, but when I mean a little bit more difficult, it is just one extra step. Okay? And here's the reason why. Let's actually start off with where we're going. We need to look at the total force that is acting on the skier. Okay? And we're not talking about gravity here, and I'll explain why that is here in just a little bit. But what we're talking about is the force of friction, and that's the pull between her and the ground on her skis. So if we go down to our triangle, we are going to be solving for the force of friction. We need to know her mass, that's how much stuff she's made of, and we need to know her acceleration. Now, from the reading, as you go through and look at this reading, we have 700 newtons, and that is her weight. So that's like the force of gravity is another way of saying weight. Remember, we just talked about that. 700 newtons. Gravity, that's the acceleration due to gravity, is 9.8 meters per second squared. Force of friction, and I need to say, this right here is not given in the problem. You just have to know that because we're on Earth, it's always going to be that. The force of friction is what we are solving for. Mass, we are not given how much matter she has. We're only given her weight. So that is an unknown as well. And her acceleration is negative 2.0 meters per second squared. So first, this is our end target, remember? Force of friction. But before we solve for the force of friction, we need to know how much stuff she's made of, how many kilograms of mass she has. So in order to do that, well, actually, I'm jumping ahead of myself. Let's do the force diagram first. The only forces acting upon her that we really care about is the force of friction. The force of gravity and the normal force, those are equal. So we don't even have to show those because they are equal. So what we need to do first, this is a question mark, this is our end target. We're given this, we know what that is. We need to figure this out first, and we can do that from the information we're given up here. Notice that she is 700 newtons, and so that is her force. Now think back to an equation that is going to use force that comes first. Okay? And so it's the force of gravity, also known as weight. Okay? The force of gravity, also known as weight, is going to equal whatever her mass is times the acceleration due to gravity. We know her weight, 700 newtons, and that's given up above, equals whatever her mass is times 9.8 meters per second squared. And that's because we're on Earth. If I divide both sides by 9.8, I get 71.4 kilograms. That's not my final answer. All I've done is I've solved for m. Now, boom, we got it. So our final equation is going to be F equals ma. So the force acting on the skier is what we're solving for. Her mass, we just solved for right here, 71.4 kilograms. and her acceleration. Remember, we're talking about her acceleration now, not due to gravity, but her acceleration, which was given right here. She's slowing down at -2 meters per second squared. And if we calculate that out, the forces acting upon her between her skis and the snow is 142.8 meters per second. Oh, sorry. The force, so it's newtons. 142.8 newtons. Okay? Now, for your problems, this is your first homework problem, and I know we did part of this one in class. If you notice, we didn't give you the knowns. We didn't give you the blanks to fill in. So what you will have to do is, as you read, write them in yourself. Right away, we got our first one. So the mass is going to be 50 kilograms. What else do we know? Force of gravity pulls her down while the force of air resistance pushes against her. After a while, she is falling at a constant velocity. Hey, that's important, because if we were to sketch out her force diagram, air resistance and gravity have to be equal. So that's something else that we know. What's nice about that is, if I can solve for the force of gravity in newtons, we know what it is right here because they're the same. All right, are there other things that we know? We know the force of gravity is going to cause an object to accelerate, acceleration due to gravity, at 9.8 meters per second squared. And you're going to be using all of this, okay? And think about this. Which one of these are we solving for? We're looking for the force of friction. Now, over here, this is our force of friction. Remember that the air resistance is a special type of friction. So that is our big unknown. That's what we're solving for. We know what mass is. Just gave it to you. We know what acceleration is. It's right there. And so you're just going to be solving like that. I'm going to leave you at that one. I think you can do that one on your own. This one up here is a little bit more difficult, okay? As you read through this, we need to solve for the mass of the engine. How heavy is that engine? So if you think about that one, you need to go through and list all your knowns. Eventually you're going to get to this triangle, and F equals ma. This is what we're solving for right there. So you need to figure out, what is the force acting upon that? What is the acceleration acting upon that? And if we look up here, we're given a couple of forces. Here's one force and here's another force, and they are acting against each other. Hint, hint, find the net force, and that gets plugged in there. For number 3, we threw a tough one at you again. Here's why. To figure out acceleration, you need to know her mass. F equals ma. You're not given her mass. You are only given her weight. So you will need to use that good old equation right there to figure out her mass. And then that is going to go into the triangle. Okay? All right, it just got really bright in here. I don't know why. But I'm going to leave you at that. Have a good weekend. I hope to see you back here on Monday in good spirits with your homework done. Bye-bye.